Good morning, or I guess good noon, good day,
Good
everyone. Welcome
afternoon.
to good afternoon. Yes, at this point, good afternoon officially. Um, Welcome to LunchBytes. Hi, I'm Steph, and I'm just going to be walking you through our code of conduct real quick as we get started with today's episode. So just as a reminder, on LunchBytes especially, and all Microsoft events, we want to be aware of others, be welcoming and respectful, be understanding of the differences, be friendly and patient, being open and to questions and viewpoints, especially in the chat, and being kind and considerate to others. If you have any questions about our code of conduct, you can visit the link at aka.ms/eventscoc. Also, if you would like, we have today's show available with live captions on Learn TV and YouTube, and you can use the selector below the video, and captions will also be available on demand. So what is LunchBytes? We are a show that airs every other week on Wednesdays, so fortnightly at lunch. So Annika, myself, and Tig will be joined by technical experts across the UK to answer your top questions about Azure. We also have a new person joining our team, which we will be revealing at the end of today's session, so stay on to hear more about them. And if you have any suggestions for LunchBytes, please let us know. We would love to hear your thoughts, what questions you have, what other topics you'd like featured on the event. Moving to the next.
I guess intros.
Yeah.
So my name is Annika. I am a specialist at Microsoft. So I work in the app innovation team. So that means all things app modernization, DevOps, cloud native. I kind of look after with our customers.
Thanks, Annika. My thing froze for a moment. So hi, I'm Steph Rogers, and I'm on the UK developer audience go-to-market manager team, working across with events and both first-party, third-party with our developers in the UK.
Hi everyone, I'm Tig. I'm a cloud solution architect at Microsoft UK. I work in our digital and app innovation space, so working on all of our platform as a service services, anything around app dev is my kind of area. So happy to be co-hosting with everyone today. So as we jump into today's session, we've got a brilliant guest with us. So Kevin, I'm going to bring you up on screen for the moment. So now everyone can see you and hear you. Do you mind giving us a quick intro to yourself and what you do at Microsoft?
Sure. Thanks, Tig. So Kevin Harris, I'm part of our Global Black Belt team as an app innovation specialist. So kind of a fancy way of saying I help our customers build cloud native applications on top of Azure. Pleased to meet everyone.
Brilliant. And I know we're going to be talking today around container apps. I'm really excited for the session. And for anyone watching live with us, we have the ability to chuck your questions into the live chat and we will get to those at the end. We'll do a Q&A section later on in the session. So please do fire your questions in live. And if you're watching after the session as well, then leave your questions there as well. And we'll try and get back to you on those. So Kevin, I want to hand over to you. The slides are all yours. Please take us away.
Excellent. Thanks, Tig. Excellent. So just quickly on the agenda, everyone. So can I go through kind of why Azure Container Apps, a little bit around the background, types of applications you can build. We're going to talk a little bit around what I mean by a cloud development environment. We're going to get hands-on with an Azure Container Apps demo, and then we're going to wrap up with some Q&A. What I'm hoping you guys take out of the session today is you get an understanding if you're already familiar with Azure Container Apps. Hopefully, essentially, the demo is going to give you a little bit of insights and a few other extra tips and tricks. If you're not familiar with container apps, you're going to walk away with a better understanding of how it can help you from a development perspective. We're going to look at the types of applications you can build with Azure Container Apps, and then explain cloud development environments and how they can help you. I know some people are thinking this area, but we're doing a lot in this area to help make reproducible development environments quite easily. And then it's always nice to essentially see a demo and see things in action. So with that, let's get started. So I think anybody who's worked with Kubernetes, it's definitely complicated. So there's lots of moving parts. There's lots of essentially challenges. There's things to manage. It's not quite platform as a service. It's not quite infrastructure as a service. I kind of call it like IaaS++. There's things I need to manage and maintain to help me run my containers. And then if I think in conjunction with that, how do I wrap security into that kind of conversation? How do I manage that platform? How do I worry about all the automation? So how do I build the DevOps processes around this? Not just to manage the platform, but all the applications on top. Then how do I integrate that into my whole developer experience? So suffice to say, it's very complicated. And really what we're talking about here around Azure Container Apps is really looking at, it's really Kubernetes without the management, or as we also like to call it, serverless containers for microservices. So the whole focus here is really to abstract away. It's very developer focused, and it's really kind of hiding Kubernetes essentially underneath the hood. So when we think of Azure Container Apps, I think of it again as that Kubernetes without the management. If we look at some of the key pieces around this, built basically around open source. So some of the key things that we've done is Container Apps is built on top of our AKS service underneath the hood, abstracted away. We brought in pieces like Envoy for doing ingress. We've leveraged Dapr, distributed application runtime, for helping you build microservices. We brought in Cada, or Kubernetes event-driven autoscaler, for helping with the scaling pieces. So what we've done is we've taken a number of open source projects, brought those into the service, grouped those together, and then offered a service up to our Azure customers. Another piece here, focusing on the apps, not the infrastructure. Like I said, it's developer focused. So one of the things we've done here is when you go to stand up an environment, doing integration into things like our application insights or log analytics or our Azure monitoring, we built those things essentially out of the box. Again, you don't need to worry about the AKS infrastructure essentially underneath the hood. That's how we help you manage and maintain that platform. You're really focused on the application pieces on top. So just focus on building those applications. We've got some nice integration around GitHub. So if I want to build some nice automation and DevOps type processes, again, I can easily build those pieces out of the box with just a few lines of configuration. Next kind of key area, we talk about scaling dynamically based on events. So the whole idea here is that serverless side, I only want to pay for what I'm using for. So if I've got something that's essentially that I need, I don't want to have to pay for it if I don't need it. So if there's no messages getting processed in a queue, or essentially there's no HTTP requests coming in, wouldn't it be great if I could actually scale down to zero and do those cost savings? Or in the event where a bunch of messages get dropped into a queue, a bunch of records get written to a database, or a bunch of HTTP requests come in, I can automatically dynamically scale my environment. So again, these are kind of those key things that we're looking for across these three areas. When we think about container apps itself, I'm going to go through a little bit of terminology on the next couple of slides. So when we talk about these things later on, you'll know exactly what I'm talking about. So one of the first things we talk about around container apps is a container apps environment. You can think of this as a virtual network boundary, or being analogous, for those that are familiar with Kubernetes, a namespace. So everything can freely talk to one another. There's no network isolation essentially in between, but this is our deployment units. We go and we deploy a container apps environment. Inside that container apps environment, we have what we call a container app. So that's essentially your host, or analogous to a single microservice or service that you're deploying, building out. Inside of that container app, we have this concept of revisions. So there's a single revision. So you think of that process as I go to deploy a service, I go to deploy a new version of that service, I can only ever have one, all traffic goes to it. The idea behind multiple revisions is I can start doing things like traffic splitting. So I can do some blue-green scenarios, I can do some canary scenarios, or A/B type testing. So I can start to divert traffic, and maybe I want to divert 10% of my traffic over to revision 2, test it out, and if things are good, then I want to move 100% of my traffic over. That's done with revisions. Replicas, I think this one's probably pretty straightforward. These are the scale pieces. So if I'm not using any auto scale or anything like that, I can have one replica or two replicas at any given time, automatically load balances traffic between the two. Or if I've got scaling in place, then the number of replicas will grow or increase as my scaling needs increase. So if I've got a bunch of messages dropped into a queue as an example, I might go from maybe 0 replicas up to 5 replicas. Or along HTTP requests, I might go from 1 replica up to 10 replicas or 15 replicas accordingly. Inside those replicas are the actual containers. So these are the same Docker container images that you're probably used to essentially building out and deploying. This is where your application code is actually hosted. In addition to the containers, we have this concept of ingress. Like I said, this is built on Envoy. So you can think of this as an HTTPS accessible endpoint. So again, everything we got SSL terminated on there. It's what's actually controlling the direction to whether I'm going to container app 1, container app 2, container app 3 instances inside. I can choose to make a container app application internal only, which basically means it doesn't get a public FQDN, or I can make it essentially external and I get a public FQDN with that. It's responsible for doing my traffic splitting. So Envoy is handling that revision, or there's multiple revisions I talked about in that Canary or A/B testing type scenario. We also have integration with GitHub Actions. So the idea here is that I can actually put something into GitHub. I can trigger off a GitHub action that can actually build the new container images, deploy those container images over to Azure Container Registry, and then those container images can get deployed inside my container app in a multi-revision type idea. So again, just some out-of-the-box DevOps integration that we're looking at. Again, try and be as productive as possible from a development perspective without having to manage and maintain any infrastructure. Next thing here is bring your own network. So obviously I can stand up an Azure Container App environment. Again, remember, environment is that isolated boundary. And it can be essentially its own standalone virtual network. But a lot of times we have organizations that want to connect back to existing services, or maybe I want to connect back to some on-prem, or I need essentially data that's inside a private network. So I can inject Azure Container Apps into an existing virtual network. There's a number of pieces around that, but that allows me to go through that process. That also allows me to essentially put something into a private, an existing network, and allows me to have an internal only endpoint, which I can then access from internal only applications or internal only services without actually publishing anything to the public internet. Next one here around logging. So we talked about the Azure Monitor integration. What we've done here automatically is I can create my own, or I can have Azure Container Apps create its own log analytics workspace, or I can essentially bring my own. So if I got an existing one that I want to use and dump logs into with everything else, I can do that. The idea here is that any of the pod logs or any of those container logs, anything going to standard air, standard out, are automatically dumped into log analytics for me for querying. There's nothing I need to do. It's just essentially automatic out of the box. Managed identity. So a lot of times we're trying to reduce secrets management. So anytime I can kind of reduce my number of secrets that I need to essentially put in there, the idea behind a managed identity is I can use a managed Azure Active Directory identity, and I can connect to other Azure resources. So instead of having to put a connection string as an example out to like a message queue, I can simply leverage that managed identity, set up the appropriate permissions, and it's going to have access to that particular queue as an example. So I can assign those managed identities to the container app itself. And then we talked about secrets management. So one of the other pieces here is I can integrate Azure Container Apps with Azure Key Vault. I can set up that configuration. Then you can see here inside my container apps, if I want to print out environment variables, or if I've got particular scaling rules, I can just use that kind of secret ref keyword that you see there with respect to a connection string. So what it's doing is Container Apps is handling the connection to Key Vault, grabbing the information, and you're just simply referencing back to that point. So from a code perspective, I don't have to put any secrets inside any of my deployment code. Switching gears a little bit from the kind of the terminology and capabilities, I wanted to focus in. We talked about Envoy and how it can help with ingress. I just wanted to drill in a little bit around Dapr and Cada. So Dapr is just basically distributed application runtime. I like to think of it as Microsoft's opinionated microservices framework. So really, it's a set of best practice building blocks. And that's what we see along the bottom here, or sorry, in the middle, around service invocation, state management, pub sub. So the idea is we've worked with the community and helped organizations build out microservices. We've taken a lot of those best practices in terms of common things that they do and they see it they're building themselves. And we put that abstraction layer in there. It's really meant to sit between your application code in the top, regardless of your language, and your hosting infrastructure along the bottom. With the idea being that through my code, I can either interact with them through SDKs, or I can interact with them through an HTTP API, or gRPC directly. And we'll see a couple of these pieces in action. We'll see service invocation, the demo, state management, and pub sub. There's other pieces there. But I like to kind of think of Dapr as that level of abstraction, but really what it should do is should help you reduce the amount of code dependency that you have, and should hopefully also reduce your code complexity. Just to kind of give you a feeling, Dapr comes with a number of different components. It's not just Azure based. This is something I can use obviously inside of Azure. It's built into a number of our different services. You can also use this in private clouds. We're seeing a lot of organizations adopt this for building microservices. So you just kind of get a feeling here, just from a state store and pub sub broker perspective, there's lots of different components out there, and the ecosystem and community is consistently growing. We talk about Cada. So this, again, is what's powering the auto scaling underneath the hood. It's Kubernetes event-driven autoscaler built on open source. There's about 35 plus scalers out there. And again, it's vendor agnostic. It's not something that's specific to container apps or specific to Azure. It's built on that open source ecosystem. Just to give you a feeling for some of the Cada rules that you can actually build out, CPU and memory kind of makes sense. The idea here is I want to be able to put some rules in place, and when those, put some rules in place so that when particular metrics are hit, my application will scale, either scale out, or if it drops down below those metrics, it can scale it down accordingly. So CPU one here as an example is when my utilization gets above 50%, I can have my application scale. Or my memory gets above 512 megs here. The more interesting one maybe is on the left. We'll kind of see this in action around the HTTP, around concurrent requests. So again, when it gets above that 50 concurrent requests, my application is going to scale. It will continue to scale up to the max. And then you can see in the event-driven column there's a lot of number of different components out there. So again, some pretty good documentation on the Cada website and some great examples there. Thinking about the types of apps that we can build. So we talked a lot about API endpoints already with respect to FQDN. We talked about the microservices in the context of Dapper. I can build some of the traditional web apps. I can build more monolithic style versus essentially microservices. Event-driven processing. So again, with the pub sub, all the auto scaling that's in there. One of the other things that we do with the Dapr integration is all the essentially adapters or essentially the connectors. So the idea here is that I can have my container apps environment maybe be sitting at 0 as an example, and messages get dropped into a queue, files get dropped into a file store, records get written to a database. And I want to respond to those events. Kubernetes event-driven autoscaler essentially can kick in, recognizes that, starts up instances, and then those instances can start processing those events. And then I can also do some of just more traditional background processing in terms of like timer jobs and things like that. So things that don't necessarily have an API endpoint. So again, a wide variety of applications as we think about this in the cloud native space. Switching gears over to cloud dev environments. So I've been a developer for, I said, like about 25 plus years, and I think we've all basically experienced this. So I built something on my machine, and it's really hard to essentially take that, and why can it not work on anybody else's machine? We're all about essentially this reproducibility. One of the things we're looking at in Microsoft is, again, how can we start spinning up consistent and repeatable development environments? When I think about development environments, I think about like IDEs, I think about tooling, frameworks, languages, scripting, all that kind of stuff. When we talk about that, this is where we talk about essentially Codespaces. So think of this as the ability to spin up a Linux dev environment in a consistent manner in typically minutes versus like hours or days. And some of the things we're looking at from a Microsoft perspective, looking at as we ramp up or onboard new systems engineers or new developers, a lot of times it's like, here's all the tooling and here's all the, like I said, the Git repos and all the connections, and trying to manage and maintain that. Can be quite tough and can be very time consuming. So we're looking at how can we consistently set up these repeatable development environments. You can think of Codespaces as a cloud development environment. You're going to see this, it's just going to be essentially running in the browser. It's got VMs and containers behind the scenes. But I can start to basically spin those up in a consistent manner. So if I need an environment and I want to use it, I can go through that process. Maybe I want to set up a different environment with a different language runtime version, or maybe a different scripting version. A lot of times, sometimes that works well side by side on my local machine, sometimes not. So wouldn't it be easy to be able to spin up a new environment quite easily? For those people that aren't sold on doing development essentially in the cloud, that same technology, kind of remote or dev containers, we call it, is powering Codespaces. I can do that with VS Code and a remote container. So the ability essentially to quickly stand up a development environment inside a container running on my local machine, and I get that same local development experience. If I start up something on, say, port 8080 as an example, I expose that out, I can access that over localhost 8080. So again, the whole idea here is to try and kickstart these environments as quickly as possible. For those that aren't doing Linux development, they're more essentially Windows development environment focused, or maybe essentially I might be looking at Eclipse or IntelliJ or maybe Visual Studio from a .NET perspective. This is where Azure DevBox comes in. And again, same type of concept. It's a cloud development environment, just focused around Windows OS versus Linux OS. So that was a quick spin through kind of like Azure Container Apps, some of the terminology, and then looking at cloud dev environments. What I'd like to essentially switch over to now essentially is a demo, but before I switch over to that, I kind of want to just kind of talk a little bit about like what you're going to see and what the kind of the scenario is. So here in this piece here, we've just got a kind of a traditional orders application. So I need to be able to expose an external HTTP API or a REST-based endpoint. I need to basically take orders in. Those orders are going to get put into a queue. In this case, we're going to leverage Dapr pub sub for that. We're going to leverage Azure Service Bus specifically for this. And then I need something to subscribe to that queue or that pub sub mechanism. We have queue reader, so it's going to process those messages and it's going to dump those into a store. And then that store is going to persist that data to essentially a key value store or state store in this case. And then the bottom line around the dashboard side of the house, just imagine you got an operations team or a business team, and they want to be able to basically get some insight into these processes. So we'll see a dashboard UI that's going to essentially help me look at the queue size. So I can see that, is there basically is there a problem with the queue? Is it getting processed? And then looking at store orders so that the business could actually see how many store orders have actually been processed. And with that, I'm going to switch over to my demo.
Brilliant. I'll add that up on the screen now, and there it is. It's live, Kevin.
Excellent. Thanks, Tag. Just quickly, and should be sharing there, I've got all this inside of a GitHub repo, so you can essentially reproduce this yourself, or you can walk through this piece. Kind of give you essentially feeling. The diagram looks a little bit better here. I'm not sure in the web software you're doing, it kind of got squished a little bit, so apologies for that. When I look at this here and I bring up this repo, and again, this is a Codespaces integration. I can pull down my code. I can do local, so I can grab like an HTTPS or SSL. So this would be a typical Git clone. When I think about Codespaces here, I can go and I can create my own Codespaces environment. I've started mine up already just to kind of essentially save ourselves a few times, so we're kind of a little bit strapped for time in terms of we don't have all day. But imagine here, I can start multiple Codespaces. I can go against my main branch. I can go against different branches there. I can set up a variety of different environments. So I've got this essentially running. As you can see, it's inside the browser. I've got a github.dev endpoint. It looks very similar to exactly what's in the repo. So when that starts up, let's have a look at this. Key thing here is this .dev container folder. So there's a .dev container.json, which tells you a number of different pieces inside here. So inside here, I can look at a Docker file. If I could actually do Docker compose as well, if I wanted to start up multiple containers as part of my environment, maybe I wanted like a Redis cache or a PostgreSQL database, or maybe like a RabbitMQ essentially database. I can start all those things left on here essentially with a Docker compose. I think of customizations. For anybody that's familiar with VS Code, I can preload extensions on here. So here I've done a little bit around C#, Bicep, one for Dapper and one for Azure Container Apps. I'm not exposing any ports by default. So again, if I did here, this would be kind of like a port forward. So if I started a service up on port 5000 or 5001, I could access that through basically like my browser. Looking down through here, I'm going to also leverage a number of features here. So I'm leveraging Docker and Docker. This allows me to build Docker container images inside here. I've got my Git integration inside here, so I can just quickly do a quick look at that. It's the latest version. I can tie it to a particular version. I'm downloading, installing the Azure CLI. I'm also downloading a particular version of Python because it's used for essentially one of these applications. So you kind of hopefully get a feeling of the different things that you can include and the different types of environments that you can build. To kind of shift gears a little bit over to the Docker file, you can see here, this is the basis. So that dev container leverages that Docker file to build out a Docker container, install all those extensions, all those features on top. And this is kind of the experience that you get on here. And again, I could do this through the browser, or I could also do this through VS Code locally as well. But again, the machine itself is still running in the cloud and behind the scenes. We can see here this MCR repo. There's a number of dev containers. There's ones for a variety of different environments. There's a universal one that installs like all the different essentially development type tooling, languages, and frameworks. I've done one specifically here for .NET and then added in things for Node and for Python for the other development languages that I'm using. You also get a feeling here. I run some package updates, so I can pick different ones. This one's based off of essentially Ubuntu, but I can pick up like Debian and other types of environments, install those particular packages. So in this case here, I'm installing Hey, which we'll use for some load testing, and Tmux here for helping with some terminal emulation and screen splitting. I'm also installing Dapr, so it's not something I'd have to have a developer do. So part of that creation process is to download Dapr and do the initialization. Hopefully you get a really good feeling around what cloud development environments can essentially bring to the table and how quickly and easily these things can spin up. So again, we're talking literally in minutes versus like hours and days to set up some of these environments. Okay, with that, let's get over to walking through the demo. I'm going to walk through kind of the preview version of the README here. And the whole idea is this kind of based on walking through a particular story. And what we're going to simulate through here is imagine you kind of deployed V1 of your application. You run into some challenges. So we're going to do some troubleshooting through that application and see how Azure Container Apps can help us with that. We're going to make some coding changes, deploy those up, and deploy a new version in a Canary type fashion. So we're going to essentially send part of our traffic over, see that in action, see how that actually looks. And that's, again, part of that Envoy integration. And then once we've got through that, we're going to see the auto scaling essentially in work. And then finally, last but not least, once we've kind of driven a bunch of data through this, we're going to see the out of the box telemetry that we get by integrating all this stuff together. Okay, so from a scenario perspective, again, we've seen the kind of the diagram here. There's a number of prerequisites. I'm going to kind of talk to this as we go along. It'll be a little bit quick because I kind of do want to get into kind of the actual, like I said, demo part. To get started, if I am using essentially Codespaces, I've done all those extensions. There's a few additional ones we need around container apps and log analytics to run some of the commands. We talked about Hey already being installed, but if you're doing this from a local perspective and you want to get this all set up, there's the instructions for installing Hey. If I need to log into my Azure CLI, AZ login, and when you're inside Codespaces, you need to use the -- use device code piece to log in. And depending if you've got multiple subscriptions, make sure you got the right default subscription essentially set up. Once you've got that, I've created these variables essentially already, and I've created this resource group and this original deployment. Because it takes about 5 minutes, so I wanted to essentially make sure we kind of had time to, like I said, focus on other things and not watch, a meter spin, so to speak. But what we can imagine here is that we've deployed the top part of this application inside here. So let's have a quick look at this corresponding template. So we've got this ARM template, and you can see some of the resources. So if you're familiar with some of these, we've got a storage account. We've got a log analytics workspace. We've got an application insights instance, service bus. This is what we're using for PubSub. We're getting down into managed environments. This is our Azure Container Apps environment that we talked about. So again, that's that isolation boundary. You can see our integration here where we've kind of connected it to log analytics and through the log analytics configuration and through app insights, the Dapper AI instrumentation key. We're getting down to resources. These resources here are referred to Dapper components. We'll see this later on when we have a look at the UI kind of near the end. This is our service bus pub sub component. And then here's our Azure Tables state store component in terms of going through. Let's have a quick look at one of the individual apps here. So this is the store app. This is that backend that's leveraging the state store. So we can see our revision mode here is single versus multiple. We're exposing that externally. We're expecting to be listening on port 3000. We see some of that secrets management essentially connected up in here. We've got our Dapper configuration, and we get down to our template for our containers. So we see our store app. We've got some environment variables. We can see that environment variable is referencing that secret ref we talked about, so I'm not storing that in here. And then we see some of the scaling rules. We'll have a quick look at some of the additional templates. But imagine now we've deployed this version 1 of the application, and then somebody comes to you and kind of goes, something doesn't seem to be working right. Maybe some of the users are experiencing maybe not the right effect, or they're essentially maybe encountering some errors. Let's look and see what can we do from a troubleshooting perspective. So we're going to grab these URLs here. Let's have a look at the store URL first. Something that we can see inside here. So you see this Azure Container Apps.io. This is the FQDN for, like, say, container apps. ECUS is the location. This unique name here in the middle is the actual name of the Azure Container App environment. And then the piece on front here, Store App, is the container app itself. So just give me a feeling for what the URL or the FQDN looks like on these things. Let's go grab these other two here, set these variables up. So you can see they're very similar. Now let's run here. So imagine here, like we're going through and we're testing something out. So let's go and have a look at the store URL. Let's see what's inside the store. Okay, so we got a test message inside there. Let's send a brand new test message, see if, is that the problem? Is something not working correctly here? And in the interest here, we'll just do test 01. Let's check the store count. So again, we had one item in there before. Let's see what our new count is. We see our new count here is 2. Let's go back here and let's check our store URL. Now here you see something essentially a little bit strange. So we passed in test 01, but all I'm getting here is a GUID out of this. So maybe let's see if we can do some further troubleshooting. Maybe the Azure Monitor integration out of the box can help me, and I can have a look at some logs and see if there's any particular errors going through here. There's a variety of different ways we can look at logs. So we talked about the Azure Container Apps extension. So again, I've got the Azure extension here. I can look at the Container Apps pieces. I can see my Container Apps environment. I can see my individual container apps. Maybe let's have a look at the back end here around the queue reader, and I can start to look at logs. I'm not going to open up these two. I want to kind of stay in the ID for this part instead of hopping around. But you can imagine these two things. Open logs is going to open me up into the Azure portal and automatically put a log analytics query in there where I can start to look at the logs for my particular container app. Log stream gives me a live log stream, so something I can look at, so I can look at logs in essentially real time. What we're going to focus on here is this query here. This is a log analytics query, essentially example. I can go through this process again. I can open the portal. What I'm going to do in this case here is just kind of stay in the IDE. This is what a typical developer is going to do. I'm going to set the workspace ID. And now I'm going to go through the process. Yeah, that's a long query when you look at it this way. I'm going to spin this out, and I can see here that I've got my 2 records. And so the problem's back here. So I still see the problems here. So maybe I need to look farther up in the stack. So let's have a look here. And let's have a look, instead of at the queue reader, let's have a look at the HCP API and see if it's coming in there correctly. So looking at that front end, okay, well, I'm seeing a little bit different here. I'm not seeing the GUID, but I'm seeing basically, maybe not necessarily an error, but an actual message here. So let's go through the process and let's have a look at, in this case, you're going to troubleshoot and have a look through your code for that. I know exactly where it happens to be in this case. So I'm going to bring up the file. I'm going to look for that to-do, and I can see my to-do message here. And have a look at this. I know if you're not familiar with essentially C#, apologies, but we can see here when we're posting to this message here, I'm not actually handling that message parameter. So it's essentially going into the bit bucket. And instead of this GUID, what I really want to do in here is pass in the message. Now, in the interest of time, just imagine I've made this change. I've compiled it. I've built a new container, and I pushed that up to the container registry. And I want to deploy that second version. This just shows you essentially the coding changes we just kind of walked through there. But instead of just completely doing like a single revision and copying over something else, I want to use that A/B or that Canary testing for doing traffic management. So I want to send 20% of my traffic that's generated to that new version so I can test it and make sure that that coding change I just made to add the message is properly reflected. So what we're going to do around that is we're going to do the deployment. So let's run that here. Well, that's going. We're going to have a quick look, and you're going to see essentially the difference between the V1 template and the V2 that we just essentially went through. So we'll compare those. Let's close these up here. We don't need those. And we see everything else is exactly the same on my container app. And this is the HTTP API one. So this is the one that's taking in those order requests. So the change I've made is to do that traffic revision. And we can see here, the current version is going to get 80% of the traffic. And the new version is going to get 20% of the traffic. This is that ingress rule essentially change. And we can see there's no changes outside of that. Let's let this essentially change take place. Should just take another moment or two. Once that change happens, next thing we're going to do here is we're going to run hey. All this is really doing is it's an HTTP request that has the ability to basically post data. So what we're going to do is we're just going to post to that HTTP endpoint. In this case here, we're going to generate 25 messages versus the single one at a time. And what we should expect to see is we're going to have some of those existing messages still seeing a GUID, but a lot of the new messages should now have essentially this hello test in there. So let's run this quickly against that. You see it doesn't take too long. You can see we got a 200, which is good on all 2,500 responses. So all my post requests were successful. I'm going to go through and check the store URL. And now we can start to see, I've got, again, that traffic splitting is helping me here. So I'm seeing this Canary deployment actually working. So I'm seeing hello here. I should see essentially a couple more hellos up here. I could go through and look at this in the log analytics query, again, that same piece again, but just showing you here for time's sake. So we can see that our change is actually looking good. So now what I want to do is I want to be able to set up and go through and put some actual scaling rules in place. So I'm going to essentially deploy the new version, or the new configuration. So it's going to change 100% of my traffic over to that new version. So everything's kind of working accordingly. I'm also going to go through the process and set up some scaling rules and look at, from my queue reader, I want it to be able to scale down to 0 if there's no messages in the queue and scale up to a maximum of 5. On my HTTP API, I want to be able to scale down from 1. So again, from an HTTP perspective, it's kind of hard to scale down to 0 because I always want a pretty good user experience. So if there's just a request coming in, I don't want any cold start times. So a lot of times that's why we do HTTP side to 1, up to a maximum of 10 to handle a large influx of concurrent requests coming in. So let's have a quick look at our V2 to V3 template. We'll see a few more changes in here. So we talked about the replicas on the queue reader. So we went from 0 to 5. We talked about the new revision management. So again, going from 0 on the older ones up to 100. And I forgot to show before, but on that previous one, we went from 1.1 to 1.2 on the previous change. And the other thing that we did here is we added that dashboard API that talks to the number of queue orders as well as the number of store orders. And then we added the dashboard app as well to actually visualize this. So let's see what these things actually look like now that we've got everything deployed out. So I'm going to grab the dashboard UI and the dashboard API URL, similar that we grabbed for the other ones. Let's have a look at the dashboard app. We're going to see this pop out. And we can see here again that URL. This is a visualization. So I've got 0 orders in the queue, which is what I expected. And I've got 27 orders in the store. Excellent. So everything seems to be working. I'm just going to run a quick little test scale here again. So now that 100% of my traffic should be shifted over to this. Let's do a quick count in the queue. There should be 0 messages. It should have processed those essentially fairly quick, which is great. And then lastly, let's just go and check the store, except this time we'll just go through. Remember, we sent 10 messages in. And we can see that we just looked in, I just kind of condensed that down, but we've got all those 10 messages here for that test scale. Now that we've got the scaling properly in place, let's see what this application actually looks like underneath load. So what we're going to leverage here is we're going to leverage tmux. What you're going to see come up here is 4 different windows. One window is going to be driving requests. We're going to drive about 5,000 requests into the application. The other three windows are going to show the number of replicas, or number of instances of the revisions for the queue reader and for the HTTP API, because that's where our scaling rules are set up. And then we're going to see how many messages are actually in the queue. All right, so let's start this up. I'm going to give the screen just a little bit more room. And we're going to kick this off. So you can see here again, the left-hand side, this is driving all those messages. We see the replica count for the queue reader, replicas for the HTTP API. And we can see essentially our store subscriber here going up as well. So what does that actually look like on the UI side of the house? So you can see here, it's essentially processing fairly quickly. So you can see the orders in the queue are going up, and they're going down, and the number of orders in the store are continually going up. So this is processing those 5,000 messages.
Kevin, what kind of
Yes.
number of requests would you expect to then start to have a load of messages fill up in the queue? Because obviously you're managing to deal with these requests really quickly, get them processed. But with container apps, is there some kind of limit to the number of requests you'd expect?
So typically, if you're starting at say 0 instances or 0 replicas, you'd probably expect that to grow quite quickly if you kind of threw all 5,000 in there. The fact that I've got an instance set up, it's really going to be dependent on how much CPU and memory I've given to an instance and whether I've batched requests in this case or not. So it's going to be really up to the individual code that you write in that case. So it's going to vary. So you can see here that all of our messages have been processed. So we've got that 5,000 plus our original 37. If we go back to have a look at our script code here, we can see here that our queue reader never got beyond 2. So what Ty was talking about there. So maybe I don't need to go up to 5. Maybe I only need to do 2, and that can handle quite a number of requests. Or maybe I need to handle 10,000 messages. How does this respond? But my HTTP API scaled all the way up to 10. So again, it was essentially going. Maybe having 50 concurrent requests is a little bit too low. Maybe that should be more like 100 or 200. So those are things you're going to have to essentially monitor with respect to metrics and adjust those auto scaling rules accordingly. So last thing I'm going to walk through here is looking at it just from a portal perspective. So I've got my resource group. We talked about all those resources. Just going to do a quick refresh inside here. We've got all the additional ones. So we've got the Azure Container Apps environment. We've got our log analytics workspace, and we've got our application insights for telemetry, which we'll have a look at. The storage account, so this is my backing store for the state store, again, where I put all the store orders. Maybe not necessarily the best use. There's probably essentially some better data technologies. Service bus namespace was used for pub sub, and I've got the individual container apps. Let's just drill into one of these from a UI perspective to see what this actually looks like. So we looked at the Dapper components. This is the state store and the pub sub that we saw in that ARM template in terms of components. We've got our logging options. Again, this is going to log analytics. There's a number of different pieces I can do here. And then I've got the corresponding applications. So let's go back here to have a look at the HTTP API. I can go through that process. I can see secrets. I can see the ingress. Again, this is whether it's enabled or disabled. It's always enabled. It's just whether this is public facing or not. I've got my Dapr integration. I've got the identity. Quickly going over here to revision management. So you can see those older revisions, but all the traffic's going to this one particular revision. I can look at containers and scale. I can go and I can look at the logs. Again, this allows me to bring up the logs for that. Won't do a query there. You guys have kind of seen that, and there's some examples. Log stream, this is the ability to look at something in real time. So again, I can look through my different revisions. I can look through my different replicas. And again, I'm getting this essentially in real time as this data is coming through. And I can look at my HTTP, my main container, or my Dapr, essentially daemon sidecar container through that process. Last piece looking through here is around the console. So if I wanted to start this up and I wanted to troubleshoot and have a look inside my container, I can connect to that and I'll get live access. So I'll just give you kind of a feeling here for This is basically the file system or the different files that are inside there. So I could look and maybe a tooling's not there, or maybe a configuration is bad, so it can help me from a troubleshooting perspective as well. Last piece we're going to have a look at here is the application insights. So again, we talked about the telemetry. This is built around open telemetry. We're going to have a look at the application map. We're going to have a quick look at this. And now hopefully this reflects kind of the diagrams. We see requests coming into our HTTP API, going into the queue reader going into the store, and the store app going into the state store. And then the dashboard API is calling into the queue reader and the store app. One of the nice things that you'll notice here is that if you remember, between the HTTP API and the queue reader, we had Azure Service Bus in between. So what this is allowing us to do is we're actually getting a trace that spans across a pub-sub boundary. And this is one of the things that Dapr helps us enable in that integration with Dapr and Container Apps. So I get a pretty good visualization. Looking inside here, so I can see that some of these requests, I got my 5,000 calls. Let's just drill into queue reader as an example. We're going to investigate some performance if we've got any kind of performance challenges or anything on this side. So we can see our traces through here, so I can look at the individual components. I've got a number of samples inside here. And I can see here I've got a couple, if I sorted this on date, I'm going to look at the top one here around kind of just drilling into one of these. And I can see here I've got a trace across the pub sub event. So this is the pub sub that goes into the from the HTTP API inside. The pub sub orders, this is the subscriber coming off the other side, and then the subscriber calling into the state store. So I get a nice visualization around kind of the call chain stack, as well as how long each of these individual pieces are taking. And I can have a look at some of these calls. So I can see that Dapper in behind the scenes is actually using gRPC to talk to that particular state store. My pub sub request here, I can see that I'm using a post request on Dapr service to service invocation. So hopefully you got a really good feeling around kind of seeing container apps in action. And with that, we're going to switch back over to the presentation. Excellent, thanks, Tig. Oh, I go back. Thank you. Perfect. So hopefully you just got a feeling for the out-of-the-box Azure Monitor integration with the log analytics there for helping with troubleshooting. We saw the ability with the Envoy integration with HTTPS, like in ingress capabilities for doing the Canary deployment and traffic splitting. We saw the auto scaling in action with Cada and driving the, when we kind of loaded up a bunch of HTTP messages into the queue and then into the store, see those things in action. And then hopefully you got a feeling for the telemetry that you get out of the box with the Dapr integration. Types of applications you can build, again, very focused around cloud native and microservices, but I can still build like web apps, event-driven architectures, and any kind of background processing. The cloud development environments, again, quickly create consistent dev experience environments, whether that's Linux environments or Windows environments. I can use that either in like Codespaces or locally with VS Code dev containers, or in Windows OS with Azure DevBox. And then lastly, I kind of like to think of it as like Azure Container Apps. I mean, you saw a lot of terminology, but I like to think of it as Kubernetes without the management, or platform as a service for containers, and very focused around developers. The idea is that you don't have to manage and maintain infrastructure. And with that, we're going to open the floor for any kind of Q&A.
Brilliant. Thanks, Kevin.
Thank you, Kevin. Great. Yeah, I'm here for the Q&A. So we have a few questions, if you don't mind answering them. So we have one from Lopjana. So could you tell us a bit more about remote and dev containers? Why do we need them? Yeah, so I think the idea here is, so imagine a local development environment, and I get everything essentially set up accordingly, and everything's good. And now I want somebody else to be able to have that same experience. So I could, give them the instructions. They can install all the tooling and all the scripting and all the different development languages and NPM packages and everything accordingly. Or I can go through and I can package that up into a repeatable environment so that, Tig could actually essentially quickly just go spin up an environment and again, have that in minutes without them having to install everything.
So the idea here is really focused around productivity and repeatability. I know sometimes I really loved my local development machine. I've been really focusing on like doing these things over probably the last like 18 months. And it has changed my perspective. So again, it's maybe not necessarily for everyone, but I do think there's a lot of challenges where quickly and consistently setting up environments is not something that us developers want to spend time on.
Makes sense. And another one from Tony. So is it safe to use container apps to host ASP net Blazor services, server apps, will it correctly identify the clients connected to the various instances of the container app?
Yeah, so with the Blazor server apps, a lot of times I think of those essentially as like the spa type applications. So I can easily host those inside something like an Nginx container or accordingly. The key thing there is getting the API correctly. So that backend piece, I'd expose that when I go to do my ingress rules, set that up to be public to true. I'll give my Blazor app that API endpoint, and then it's going to go and find the corresponding one accordingly.
I think those are all the questions today.
Yeah, those are from the live chat. We've got a couple other questions I think we can jump to. Really appreciate the way, Kevin, you showed the interaction with container apps through the CLI and doing a demo completely through that, and then at the end giving us that portal experience as well. So if people are looking to develop on their own like just development version of container apps, not in production, then you can play around with the portal like quite quick and snappy. But if you want to go deep with the CLI and make sure everything is repeatable, like what you've showed us there, then you can do that with CLI. So that was brilliant. One of the questions I guess we wanted to get to was, can I use Azure Container Apps for internal facing applications that connect to non-public endpoints?
Yeah, so if you remember from when we went through the presentation, we talked about the basically internal VNet deployment. So this is the ability to connect and inject into an existing virtual network that's going to have connectivity there. So I think we have a lot of customers, they see like those URLs, they see the public endpoints, and they think, okay, it's really only for public HTTP API endpoints. Behind the scenes, when we go and inject into a VNet, we get an internal load balancer that I can then attach. It gets a private IP address. I can attach a DNS name to that. And now through something like ExpressRoute or another, say, service inside that particular VNet, can just use that FQDN or that DNS endpoint to talk to all those container apps environments. So we see that actually quite common for internal only or internal hosting services or somebody that wants something private.
Brilliant. And then the next one is, can I install my own daemon sets or CRDs needed for a service mesh?
Yeah, I get this question quite often as we're looking for, again, that right level of abstraction for, yes, it's Kubernetes without the management, but as a result, it's flexible, but I still think it's an opinionated platform as a service. In this case, because we're managing that AKS environment underneath the hood, we're not allowing you to basically bring your own daemon sets or CRDs, which would be required for, like I said, service mesh. A lot of times we're looking for that integration through Dapr. We're looking at through essentially Cada in that kind of context. It's really about bringing your own container workload and leveraging those pieces that are there. If you absolutely need a service mesh, you need that type of functionality, or maybe you're building some custom CRD, that's where we would then look to, unfortunately, have them deploy that on top of our Azure Kubernetes service or AKS service.
Okay, and then finally, do I have to use Dapper, Cada, and Envoy? I know we've got these sort of built in, but is there other options for people who want to do different scenarios?
Yeah, so let's start with the end one. So Envoy is not really an option. It's there, it's used for ingress, regardless. So it's there for like the traffic splitting. It's used to help you go to like container app 1 versus 2 versus 3 accordingly, whether that's internal or external. So that one's not much of an option, but we have seen some customers that want a more configurable experience underneath the hood. So they use the ingress that's there around Envoy, and then they might put something like traffic in behind it. That way they've got control over those ingress rules and maybe some very specific, like I said, plugins and everything else. On the Cada side, if you're using auto scaling, use the auto scaling rules, then you're going to use it. If you just kind of set your replicas to 1 or 2 or 3, then you don't have to use it. So it's there if you want to use it, but you don't necessarily have to use it if you don't need auto scaling needs. And then Dapper is kind of an interesting one. So you saw the telemetry that was there at the end. A lot of that's due to the Dapr service-to-service integration and its telemetry or observability building block. So when I put and instrument those things pieced through Dapr, you saw the pub subs, the ability to see from the HTTP API over to the queue reader to span that trace. If I didn't use Dapr, then I would have to essentially do that glue together in that kind of context. You don't have to use Dapr, but there's definitely benefits. And again, I think that's a pros and cons around that opinionated microservices framework. And at the end of the day, if Dapr doesn't help you and increases your code complexity and code dependency, then it's probably not for you. But we've seen a lot of organizations benefit from it.
Mm-hmm. Okay, and I said last question, but there's one more that popped up from Giovanni. And Giovanni says, is there some guidance on when we should use Azure Container Apps versus Azure Container Instances? And I know we've got obviously a lot of different container hosting platforms now with Azure.
Yeah, sometimes I think it's almost too many. Sometimes choice is good, sometimes choice is bad. So I think the biggest piece, they're both serverless, like in my eyes, in that kind of context. I think the biggest piece with container apps to me is the ability to add the scaling. So I don't get a load balancing endpoint with Azure Container Instances. They're really for running like individual instances in that kind of context. Whereas like container apps, it's like an HTTPS endpoint, which is great for like SSL and TLS. I get the ability to do the scaling rules. I can have my application automatically load balance across 2, 3, 4, 5, 10 replicas. And I get that visibility around the auto scaling. Some of the scenarios I think Azure Container Instances are really good for that I see a lot of organizations leverage. If I just need to send just a single job, maybe essentially it has GPU capability, Azure Container Apps essentially doesn't, so there's some nuances there. But if I just need to essentially go like kind of run a job, have it to completion and finish, I think it works great. I see Azure Container Apps for a lot of organizations if they want to be able to drive load. So I can quickly set up a number of Azure Container Instances kind of in different regions, plugging those in. If I've got more of a monolithic, or I just need kind of like a single instance piece, and I want to be able to expose that, Azure Container Instances actually works like quite well. So I can just essentially put it on there, give it a public endpoint, assign an FQDN to it, and away I go. So hopefully that answers your question.
Yeah, it does. Thank you. Thanks, Kevin, so much. Unfortunately, we've run out of time, and thank you to everyone for sending in your questions as well. We're going to jump onto the developer news radar in a moment now. So Kevin, just want to say thanks again for having us. And if anyone has any questions for Kevin post this show, then feel free to chuck them into the YouTube comments or reach out to LunchBytes@Microsoft.com.
All right. Thanks for having me.
Thank you.
Cheers, Kevin. Okay, very quickly with developer news radar, so I know we've only got a couple of minutes, but just wanted to make a few announcements that obviously since we've had our Ignite panel recap session, there's been some more announcements on the Azure side of things. So one of the things was generally available is Logic App standard support for functions runtime v4. So we were just on the v3 runtime, and that's being going out of life at the end of this year. So v4 is now available in Logic Apps. So over the next month, existing Logic App standard instances will be migrated automatically to Azure. And so functions v4, unless they've deployed using the NuGet methods or NuGet, or you've changed its configuration to pin a specific version of the extension bundle, it will migrate automatically for you. We're also having some API versions being retired for Azure API management. So those before the 1st of August 2021, those are being retired. Okay, other updates. Public preview for Azure load testing. It now supports authenticating with client certificates. So you can use your certificate that's stored in, for example, Azure Key Vault, along with your load test. So that's brilliant. And we've done a session in the past on Azure load testing with John Metzger as well. So do check that out as well. And relating to container apps, we've got a public preview of TCP support for container apps. So with this feature, currently in public preview, you can communicate over a custom TCP port now. Additionally, a container app can expose a TCP port externally. And then lastly, on the GitHub side of things, there's now dependable alerts at the enterprise level available through the REST API. So before we've announced that it's been org level, now it's enterprise level. And then secret scanning now stores encrypted secrets as well. So in the past, where sometimes you've not been able to see what the secret was that was detected, now you can with one of the recent updates that's come to GitHub. And so there's good things to check out. Okay. Steph, I wanted to hand over to you. We've got a couple of announcements on the community side of things.
Yeah, absolutely. Oh, you can't see it all very well, so I'll go ahead and put it in the comments, but we have a community call out section right here where we want to highlight all the amazing communities. We are out of time, but you can check out our community website at aka.ms/UK developer community at, there it is in the chat. You can look at different communities local to you. We also have some really great events coming up with open hacks and adventure days. So if you have any questions about some of these virtual events, please reach out to your account team. And with that, we will quickly move to our next announcement, and then we'll have to hop off.
Yeah, so just highlighting that the last LunchBytes session we had was all around Ignite panel recap. So if you missed announcements for Ignite, that's worthwhile checking out. And the reason why I raised this is because actually we've now got a playlist on YouTube. So if you go to aka.ms/LunchBytes, you can now see all the available LunchBytes sessions that we've done. So if you've got a few hours to spare, you want to go binge some technical content, then this is the place to start. And now, Asta, I'm going to bring you up on screen. There you are. Welcome to the team. Do you mind giving us a quick intro to yourself?
Hi everyone, it's really great to join the team. So my name's Asta and I'm a cloud solution architect intern at Microsoft. So I'm also in the app innovation team, like the rest of the team in LunchBytes. And yeah, really excited to help out and create some amazing content.
Great, yeah, it's brilliant to have you here. And yeah, looking forward to seeing you on the next sessions over the coming months. Okay, so the next session is 2 weeks' time. I'm going to be presenting alongside with Dave Phelps. We're going to be doing a session on GraphQL on Azure. So I hope you can make it for that in 2 weeks' time. And once again, thanks, Kevin, and thanks everyone on the LunchBytes team for today's session. Hopefully see you soon.
See you all. Bye.